Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello everyone and welcome back to GOTO Unscripted. My name is James Lewis and I'll be talking today. I'll be in conversation with Richard Feldman. Welcome Richard. I think we're just going to explore some ideas around things like language design, because Richard will introduce himself in a moment, but is the creator of the programming language Rock and the author of the wildly successful, I'm told he paid me to say that, Elm in Action. So we'll just have a conversation about languages and programming in general, I guess. But welcome, Richard. Maybe you could introduce yourself.
Yeah, thanks. Created the Rock programming language, which is still kind of a work in progress. But wrote the book Elm in Action, and also spent a lot of time with Rust. And later in the conference, I'm going to be talking about Rust and Zig, and sort of together. Very interested in language design. You were telling earlier before the cameras were rolling about you were there when Rich Hickey announced Clojure at the conference.
I was at Yahoo. I think it was still Yahoo at the time in Aarhus in Denmark. And yeah, Rich turned up and sort of blew everyone away with this announcement of Clojure. And obviously, it's been pretty successful since. I mean, we've had many projects in Thoughtworks that have used Clojure over the years, and I know. There's a consultancy, Juxt, in London that is very successful as a pure Clojure consultancy, actually, in the fintech, mainly in the fintech industry. What do you think, actually? I mean, it'd be interesting to get your take on that. Do you think there are different domains where different languages are more or less suited?
Well, there certainly seems to be an element of suitability, but there also seems to be an element of just sort of cultural momentum. Like something will get traction in a particular domain. Maybe it is, maybe it isn't, like especially well suited for it, but then it just sort of perpetuates. So the example that comes immediately to mind is Rails and Ruby.
Right.
I mean, if you're to zoom out and say, aliens land, and they're going to pick which of the languages, the programming languages are going to become really big in web development. I don't know why anyone would say, well, it's going to be the one created by the Japanese guy that's only big in Japan right now. That's the tagline is let's make programming fun.
Right.
That's what's going to be used widely in industry, and blow up in the next 10 years. I don't think anyone would have predicted that. So I don't think it's necessarily just about, like how well suited it's like the perfect fit as much as it is like, well, one person like DHH made Rails, that really resonated with a lot of people. And because Ruby was the language that he chose to make that in, he could have made it in Python. He would probably say nothing else but Ruby would have inspired me to make Rails. But I think you could pretty easily make the case that someone could have made something that was as successful as Rails in a different language.
I think you mentioned Python. That's super interesting because I remember when Rails was massively taken off, and in Thoughtworks North America in particular, and in India, Rails became a huge thing. I mean, our founder at the time, he was very taken with it, and there were some very persuasive people who were talking about it. Obi Fernandez, for example, and it seemed that we suddenly had a load of projects in North America and in India using Rails, and we still do actually. I think the world's largest Rails project was a Thoughtworks project in Atlantic City, maybe.
Really?
But the weird thing is, it didn't spread to the rest of the countries that we're present in. So the UK was still and remains still very much a Python shop. Mm-hmm. So maybe it's not just a domain-specific application. It's also there's also like a geographical thing going on.
Well, I think you could generalize that to culture. It's like there's certain pockets of culture that might be geographic or might be just other things that contribute to those things. I've spent an increasing amount of time over my career like learning about like why things get adopted and why they don't. And the more I learn about it, the more reasons I discover. And it seems like there's just an inordinate amount of variables. And as programmers, we like to look for simple solutions and simple explanations for things. But much like with, I would say another thing that has been true the more I get into it, the more variables I discover has been like performance optimization,
Right.
where like when I was in school, all the focus was on big O notation and like, what's the asymptotic complexity of this algorithm and stuff like that. And now I'm like, that's like this much of it. That's the tip of an extremely large iceberg. And all the stuff I just had no idea about. And similarly with adoption of languages or technologies in general, it's like, I would have thought, early on, it's like, oh, well, people use that because that's the best thing for it. What else is there? And there's all these cultural and, all these timing factors that come into it.
I remember doing a thing with one of my colleagues about programming language adoption, and certainly it was as much about culture availability as anything else. It seemed, are you better off picking something where there's a lot of people out there who are you can just hire for it?
Yeah.
Or another example would be a counterexample. We had a publishing client who deliberately chose Scala because it meant that they could offer a really fun or potentially more fun programming environment for developers to come in because they couldn't pay the same rates as the banks. Yeah. So there's this almost like trade-off is, do you offer this like more interesting, exciting environment versus, okay, just whatever it is, €1,000 a day for just a standard Java developer in a bank.
Yeah, I think that's an underrated trade-off. Is that if you're a company and you're considering a novel technology, and I've talked about this before in other settings, but this is something like my previous job and my current job, we both have used Elm on the front end as like the entire front end, not just like a little part of it. And really embracing that means that you get to be very selective about who you hire. Like we just filled a front end role, and the recruiter was talking to me about, we, hired this guy, and it was really close. We had to decide between him and a couple of other people who really wanted this role. And, usually it's the other way around where employers are like, I just want to find anybody who can fit this description that actually meets our criteria. And it's really hard to find people, but you flip the script when you're offering a technology that people want to use, but that not a lot of employers are using. Yeah. And that's almost, sort of like a self-fulfilling prophecy in the sense that if enough employers do that, then it flips back around. But then by then it's mainstream. So then it's not notable anymore. And now you are saying, oh, well, I can just find lots of people to do it because it's become mainstream. But I think most people are aware of that side of the dynamic, but they're not familiar with what happens before a language gets mainstream and what the dynamic's like over there.
Yeah, I guess the big question is, did the person you hire have 25 years of Elm experience?
Let's see, Elm was created in 2011, so yes. Of course.
Which I guess comes to Elm, I'm going to throw my hands up and profess to not generally being any good at all at front-end software development.
It's fine.
Not something I've done in my career, to be honest. Any front-end that I program tends to look like a bad implementation of Excel. That's pretty much it.
Well, Excel's not an easy thing to implement, so,
Well, funnily enough, coming back to Ruby, there's the creator of RSpec, Nicholas Nielsen. He showed me an implementation of a spreadsheet written entirely in the constant missing method.
Wow.
Because if you think about how spreadsheets you have, you're addressing by capital letter first.
Right.
And if you didn't have that defined as
that's hilarious.
It would catch
Wow.
it, and you could do all the calculation in constant miss. Anyway, that's by the by. Have you been surprised at the adoption of Elm and how successful it's been?
Yes, but maybe not in the way you might guess. So I would have thought that it would have been sort of all or nothing. I would have thought that either a language like Elm would just take over the world, or it would just peter out into non-existence and people would, walk away from it. Because I've seen that happen with, various different languages. Like TypeScript would be an example of taking over the world. That's happening right now. And then CoffeeScript would be an example of something that sort of petered out and, is basically not really used anymore. Elm seems to have sort of found a solid niche. There's just a chunk of people who are like, yes, this is how I want to do front-end development, but it doesn't seem like it's on track to take over the world. It seems like it's on track to be, well, it already is like a self-sustaining thing, and it seems like it's on track to sustain. So that's something that we've seen with a lot of backend languages. There are plenty of backend languages that are not no language is taking over the whole backend. It's just people have preferences on the back end world, whereas on the front end, it's very much been you can use any programming language you want as long as it's a JavaScript dialect. Like it can be JavaScript or it can be TypeScript or it can be CoffeeScript, all of which have the tagline, it's just JavaScript, or implicitly in the case of JS itself. And then all of the other ones have been really like kind of niche players. But if you think about it, I mean, like on the back end, it's really common to have a language that has like, low market share, but is like quite a healthy, active community with lots of people in it. It's just on the front end, that's like a weird thing to be. And Elm being a front end focused language, I just never guessed that. I thought it was like, oh, it's either going to take over or it's going to peter out. I didn't expect it to become more like a back-end language, and that it's just, there's a chunk of people who like to do it this way, and it's fine.
You mentioned TypeScript, so that's the elephant in the room in some ways, right? So what would you ascribe to? Can you see sort of any particular reasons that TypeScript has sort of eaten the world, or there's some discussion about it at the moment? But
yes.
In comparison, because I mean they're both on the surface, fairly similar ideas, really.
Elm and TypeScript, or which two things?
Well, so essentially taking something that's going to be able to be used in the browser, but offers maybe a safer, allegedly more productive perspective on programming front end. So
I think like when I think about comparing Elm to JavaScript and TypeScript to JavaScript, and I guess also TypeScript to Elm, like TypeScript and JavaScript, I mean, TypeScript is really like, this is going to feel like JavaScript, but with types. Elm is like, I am a programming language and I run in the browser. It really has no relation to JavaScript other than like as a compilation target. So actually you mentioned like Clojure earlier. I would liken Elm to Clojure, except like even more separated from the host. Like Clojure is very much like, I'm a programming language, but I intentionally have some Java-like elements inside, but I don't think anyone who's written Clojure and has written Java would say like, oh, this is a Java dialect, But they do like share data structures and things, whereas Elm, it's even less than that. It's really just kind of like, well, we use the same like string representation under the hood and stuff like that, but that's kind of about it. It's really like, this feels like a totally different programming language. Whereas TypeScript feels like this is a new take on JavaScript, I would say.
And I guess that's a good comparison, I think, with Clojure as well, because if you look at something like two different JVM languages, like Clojure and Scala, say, I mean, most people's entry point into Scala was programming Java without semicolons. That was the old joke, wasn't it? And whereas Clojure is a fundamentally different paradigm, fundamentally different way of approaching writing code.
That's a good point. Yeah, I've talked to people in the Scala community who talk about there being sort of three different ways people do Scala. So one is like Java++, or Java without semicolons, maybe. Another is, I want a hybrid OO-FP language. I want a language that has a lot of OO support and a lot of FP support, and I'm going to use them together, and I can't get that from Java. So Scala is the way to go. And then the third group is, I want Haskell, but my boss won't let me use it, so I'm going to use Scala as my Haskell stand-in. That's also a popular way of using it. But I don't see the same thing in Clojure or in Elm. It's like pretty much nobody's using Clojure as like Lispy Java. Everyone's using it as like Clojure. The same thing in Elm.
Maybe a bit random, but when Google first sort of published is the wrong word, but created and then started talking about Dart, the programming language, we actually had that we have a thing called the Thoughtworks Technology Radar, which we every 6 months we sort of take new stuff and sort of think about it and assign it like an assess or trial or hold or whatever. And actually at the time we sort of said we put Dart on hold on the basis that we were super worried that adoption was going to be limited by the fact that other browsers weren't going to be able to weren't going to jump on board, right? Because it was very much a
part of it.
The VM part of it. And of course that's now come back, right? I mean, it shows what we knew. Like some years later, we now have Flutter, which is kind of very much being adopted quite rapidly at the moment. Actually, I kind of find that kind of interesting, where you've got something that sort of at one point in time wasn't actually wasn't really the right time for it to be adopted, but then later on, it suddenly is the right time.
Well, I think that's a great story. That's really one of the. I mean, Dart to me fits the same category of adoption as Ruby, where it existed for quite a while. Like Ruby was just big in Japan for a while. Ruby was created to be like, let's make a language. I mean, Mats was like, I want to make a language that's fun to program. That was the word he used. I mean, Dart, as I understand it, was created basically because of the VM, because Lars Bach, had done V8 and was frustrated by how difficult it was to do certain optimizations around JavaScript. And he was thinking, if we just had a different language that felt a lot like JavaScript, but which was different in certain very specific ways. We could make a much more efficient VM implementation out of it. And that was kind of the motivation behind creating Dart. And, if you think about it, why would people want to adopt that unless you're a VM author? Like, it's like, okay, but I'm over here doing my web development job. What's the pitch to me? I don't care about how easy it is to optimize the VM or how optimized it can be. I just, especially since you and your team, Lars, did such a good job making VM a lot faster, or V8 a lot faster.
Thank you, Eric, as well.
Right? Yeah. So like, what's in it for me to switch from JavaScript or CoffeeScript, which was big at the time, to Dart? But then the answer comes with Flutter. And again, you could make the point, Flutter didn't have to be implemented in Dart, but it was. The same way that Rails didn't have to be implemented in Ruby, but it was. And that, if you look at like what percentage of Dart usage in industry is not Flutter, I would guess it's very small.
Yeah, right. Yeah.
Similarly to Ruby and Rails. It's like overwhelmingly Rails, it's overwhelmingly Flutter. So this is, the term I use for this is like the killer app adoption explanation. Is like there's some application of the language that's so popular that it just brings the language's popularity along for the ride because people want to use that thing, and that thing is implemented in that language, and they want it so bad they'll use whatever language it happens to be implemented in.
That's actually quite a nice segue for me to go to talk. Want to talk a little bit about Rust, maybe? Okay. Because you mentioned about your new language, Rock, that you're writing.
Yes.
We'll come on to that maybe in a
Sure,
minute.
Yeah.
But you mentioned about the fact that the compiler is written in Rust, and that's another. I think we are starting to see in terms of Thoughtworks and our clients adoption in very specific areas.
Yeah.
For Rust. Specifically, there's lots of interest, for example, in automotive or sort of safety critical systems and these kinds of things. What made you choose Rust yourself?
So this is a little bit of, we're going to bring a little of my talk into this conversation.
This will be published a lot later. So
yeah, exactly. It'll be fine. So basically, it's really important to me that the Rock compiler be very, very fast. I really want it to run as fast as possible. And I certainly did not want to get to a point where I'd built this whole compiler out. I say me because that's what I was thinking at the time. Now it's a bunch of people working on it, and a lot of them are better at this stuff than I am. But I didn't want to end up with a compiler that was very feature complete and very done. And then we're like, and we can't really eke any more performance out of it because of the language we've chosen that is like garbage collected and whatnot. And there's just this ceiling we cannot possibly exceed, no matter how many hours of performance we put into it, unless we rewrite it in like a Rust or a C or C++ or something. And I really thought, I don't want that to happen. I want this to be as fast as it can be, and I don't want to hit that ceiling. So that meant one of a couple different options. One was do C or C++, which I'd had some really bad experiences with earlier in my life around like getting memory unsafety related bugs that were really, really painful to track down. And I basically was like, well, the pitch of Rust is that you have the maximum memory ceiling, but somehow, and I didn't really know how at the time, somehow they do compiler things to help you not run into those problems. And so I thought, well, that seems like kind of the only game in town that fits all my criteria. There's no performance ceiling, and yet I'm not going to get these memory and safety bugs that are a nightmare to track down. So I kind of took the plunge, and I'd done a little like toy thing in Rust where I'd built a little command line app that I'd never quite finished before. So I had a feeling for the language, and I was like, okay, I can get this. I can stumble through it. And now I feel very comfortable in Rust. But when I started out, it was like, just because I had this list of criteria, and that was the one language that popped out,
right?
Yeah.
And you got to choose as well, which is the nice thing, right?
Yes, very important, yeah.
I remember my colleague, Eric Dunneberg, he's based in Germany. He's the head of tech at the moment in Germany. And he did a really great talk at one of these events on Rust. And it was back at the time when not that many people were adopting it. So it was quite early on.
Yeah.
And there was a bit of an overview on why Rust, and again, actually why some of the other languages that have started to appear around, which, like Go and, oh God, I always forget the Apple one. Swift, is it?
Yeah, Swift.
And why they've, what problems they were attempting to solve, which is around memory safety. It's something like, I can't remember the exact number, but some very high proportion of bugs.
70% of CVEs,
right? So this was around that. But he did this lovely little thing at the end of it where I think he didn't. It wasn't Conway's. It wasn't Game of Life, but it was a similar kind of agent-based kind of implementation. He always uses that when he's learning a new language, right? You need something, you need some framework to understand when you're learning a new language. And he started running it, and he was sort of running multiple iterations of it, and he was looking at the performance. He was like he was like, this is actually a lot faster than I think it was a JavaScript implementation, ridiculously faster, orders of magnitude faster. But he thought, actually, I thought it'd be better than this. And he realized he hadn't turned off, and I'm going to get this wrong, but he hadn't turned off there's some kind of setting in Rust, I think, which you can turn off. It's like production mode versus. Does that make sense?
There's an optimization flag.
Yeah, right. And he'd forgotten to use that. And then suddenly it was like 3 orders and 4 orders of magnitude faster. Which I quite like as an idea, yeah.
Yeah, that sounds about right. That flag makes a big difference.
Yes, right. Yeah. How did you go? Okay, maybe let's generalize it. There's Rust in particular.
Yeah.
But which is spiky, I'm told. I've only read some books. I've not really done any serious attempt to learn it. But I'm informed it's quite spiky. There's quite a adoption curve. How do you go about adopting or learning new languages?
Yeah,
or do you know enough now that you just go, it's that sort of thing?
Well, it's funny because you mentioned I know a lot of people who like to do the same. Like, I'm going to learn a new language. I'm going to pick a project like Game of Life that I'm very familiar with and implement that in the new language. I'm almost the opposite, where I always need to have some specific project in mind first.
Right.
Where I'm like, I want to build this in this language or this whatever the new technology is. And then that motivates me to push through whatever the learning curve is, because I'm like, well, I can't get it any other way, so I got to do it. Whereas, so I guess maybe I don't tend to just seek out to learn languages just for the sake of learning them. It's more like there's some problem I want to solve. This seems like the right tool. All right, let's go. So I don't think I've ever done
and obviously picking the easy things, right? Right. Just write a compiler.
Well, yeah, right. Yeah, I'll just write a compiler, which I'd never done before either. But I guess. I don't know, at least for me, the hard part of learning something new is generally sort of finding the motivation to climb over these obstacles that I hit, whatever they might be. And I also am aware of, there's definitely an element of, if you pick a project that's too hard and a language that's too hard, and those can kind of compound for sure. But I had previously done this little command line app in Rust where actually the motivation there was, it was the Elm test runner, and now there actually is somebody else separately went off and did a different Elm test runner implementation in Rust. But at that point, it was actually mostly just frustration with Node.js APIs, which is what the one I'd written previously was in. And one day
not because Node is blazingly fast.
No, not. It was nothing to do with performance. It was really just like I was like, I want to write this in something that has a different set of APIs, shall we say. And I didn't really want to use Go because I didn't have any particular interest in Go. And I was like, well, I want to learn Rust, and I want to have a code base that I can maintain that's not Node.js anymore. So I'm just going to rage rewrite it in Rust. And I got like 70% of the way through that, and I was like, okay, I have a feel for this language now, and feels I'm not great at it, but I at least can stumble my way through doing things. And I have this code base. And then, as happens with many projects at around the 70% mark, I was sort of like, okay, yeah, but do I really want to do the rest of the work to get this over the finish line and then maintain that code base, and then new contributors are not going to know what they're doing, and so on and so forth. So I ended up kind of putting it on the shelf and not finishing it. But somebody else separately went and did it. But yeah, I definitely would agree with the learning curve on Rust is definitely a downside. It's quite high, and it's not. Like some languages, I think, have a high learning curve because, like Haskell, for example. Haskell, I would say, has a high learning curve in part because a lot of the things you're encountering for the first time. Like, I've never heard of these concepts before. I don't know what they're about, and there's just kind of a lot of stuff to learn. In Rust, I would say the thing that's the hardest about the learning curve, and people often talk about fighting the borrow checker. So the borrow checker is kind of Rust's like marquee feature. It's what sets it apart from other languages. It's what gives you the memory safety. But at the same time, it's not so much like you can just sit down and like once you wrap your head around the borrow checker, you got it and it clicks. It's more like there's just a whole lot of things that all fall under the umbrella of borrow checker, but they're various different scenarios. And I remember one time, it took me, I'm embarrassed to say, I think it was like 2 months or something, where I couldn't figure out how this part of the compiler was blocked, and I couldn't figure out how to do the thing I wanted to do. And borrow checker gave me an error, said you can't do this. And I was like, but why not? I know this is possible. If this were in like C or something, I would just be like, here, take this thing and put it over there, put it on this thread. And I was like, no, you can't do that. And I was like, well, why not? Why can't I do that? And I eventually realized, I was like, wait a minute, do I just need to use, it was iter mut versus iter. And what iter, the difference is iterating over these, iter is like, I want to iterate through these things, and iter mut is, I want to iterate with the possibility of mutating them. But it didn't occur to me to use iter mut because I didn't want to mutate them at all. But the problem was I needed to use iter mut in order to prove to the borrow checker that I had permission to mutate it, which meant that it was safe to put it on a thread. So in this case, mutable was sort of a stand-in for is uniquely owned by this particular instance. And I switched it to iter and iter mut, and this thing that I've been stuck on for like 2 months, it was like, okay, right? And
I would love to have been in the room at the time. It was like, oh my God.
But I bring this up as an analogy of like, even though I had that, I already knew the mental model of like, mutable means is uniquely owned and therefore has permission to do certain things. It hadn't occurred to me that I didn't like put 2 and 2 together with the implications of that like, oh, if I want to put these things on threads, I need to iter mut, even though I'm not going to mutate them. So there's just a lot of stuff.
It's almost like you're being more restrictive than you need to, in some senses, right? But because the mental model is, okay, this is a really restrictive memory model, so I want to be overly restrictive.
And I think in this case, it was more of a language terminology thing, in the sense that I think if instead of calling it iter mut, they called it iter unique. I'm not saying that was they should rename it. It's more just like if they called it that, I think I would have more quickly realized like, oh yeah, I need to in order to hand these things out to the threads, they have to be unique, because the whole point is I don't want them to be shared across the threads. That's like another aspect of Rust that makes it tricky, is that part of what the borrow checker does has to do with when things are like available in memory, like when they're in the lifetimes of like when they're alive and when they're can be reclaimed. Also about mutation access, like this thing can or cannot mutate it. Also multi-threading and like which things have permission to mutate things, which has to do with like preventing data races in addition to memory safety. So there's just a lot of different things that all kind of come together and put it all together, you get a big learning curve.
So I mean, you've obviously you spent a lot of time building this compiler, clearly, because the 2 months were. But the aim of it, presumably, is to compile this new language. So maybe you can talk a bit about Rock. And
sure.
What makes that unique, and why you decided to get a new language.
Yeah, so Rock, the tagline is fast, friendly, functional. And I was just talking to Dave Thomas, and he mentioned that he knows someone who made another language. I think it was it K, maybe? Which the tagline was fast, fun, functional, which I did not know existed, but it's very, very close to what I independently came up with. But the basic idea is I really wanted a language that felt like Elm in terms of the ergonomics and the overall user experience, but which is for, instead of being focused on browser-based UIs, which is sort of Elm's bread and butter, I wanted it for sort of not just like one other domain, but sort of like the long tail of domains. Right. So I'm not just thinking about like servers and command line apps, although those are the two things that people are most interested in it for, or desktop GUI applications, which I'm also interested in, but also things like
if you can replace Electron, the world will be a happier place. Anyway,
that's a very big challenge, right? It's not an easy thing. There's a reason Electron's so popular. But definitely, I've always run into these little cases where it would be, and Vim Script is going to be the one that comes first to mind. Like I want to write a Vim plugin. I don't want to learn Vim Script. I don't want to use Vim Script. I've heard, it doesn't have a good reputation as a language. But what I want to use is I want to have like an Elm-like experience. This really pleasant experience I'd had with Elm. But Elm being a focused language is not ever going to get into that. Yeah. There's never going to be an Elm for Vim Script. So I wanted to make a language that was capable of being used in lots of different domains while still feeling like it was to some extent domain focused, like how Elm is. So without getting too much into how we achieve that, there's this basic high level concept of platforms and applications. So what we mean by that, an application is basically just like, my project, I'm building a thing. A platform is something like a framework in the sense that it's sort of the foundation that you build on. You never have more than one platform, you always have one. But unlike most languages in Rock, you have to pick a platform. There's no such thing as like a platformless Rock application or like a frameworkless, if you will. And the reason for that is that platforms, although they kind of feel like frameworks, they're scoped differently. So a framework typically, like let's use Rails for example, Rails will be in charge of things like database access and how do you do routing and like request handling and stuff like that. In Rock, sure, that would be true too, but also it's going to be in charge of all of your low-level I/O primitives. So it's going to say, here is all the things you can do in terms of HTTP and database access and this and that. And for a web server, maybe you have like the full range, but you probably don't have like reading from standard in on a web server. Does that really make sense?
Yeah,
maybe you leave that one out. Now, a better example though is, let's say that you want to make a platform for like a database extension. Well, now you're writing like a Postgres extension. Do you even want to have like network access?
Right.
Do you want to have arbitrary file system access? Does that make sense? So the way most languages do this is like the standard library has all these really low-level I/O primitives, and then there's certain use cases where it's like, don't do that. Don't write to that. But a problem this creates in the ecosystem for these sort of long tail of use cases is that you use a library, and that library is like, oh, I can just like create a tempter and put stuff in there, right? And it's like, I don't know if I want you doing that on my database server, And so the idea is that by basically making it so that you have to pick a platform, the platform says which primitives are available, the ecosystem will sort of naturally design itself to be accommodating to that and to be aware of that and to be like, oh, if I choose to use a tempter or whatever, that's going to restrict which platforms I could potentially run on. If I read from standard in, that's going to restrict which platforms I can run on. Another thing is that the platforms, because they're in charge of the I/O primitives, they can implement certain like sandboxing features. So one example of something that I personally hope someone builds in Rock, because they now can, which I would love to use, is a sort of sandbox script runner. So for example, like this is something that Dino has at the language level, but in Rock, anyone can implement it in user space, which is basically like, if I download a script from the internet and I run it, I know it might mess up my machine. Like it might give me a virus. It might write to, places on my disk that I didn't want it to write to. But because in Rock, you have this platform application split, if I have a platform that's like, I'm a command line runner, but I'm a sandbox command line runner. And because I'm in charge of every single one of the I/O primitives, I can say, yeah, look, I give you all access to all the I/O primitives, but guess what? If you try to write to this part of the file system or you try to read from there, I'm going to prompt the user, and there's nothing you can do about it. So it's now as safe as a web browser in terms of,
super interesting.
But at the command line. And I would love to have that because I run stuff that I download from the internet all the time, and I'm either doing it in a VM.
You hear it here first, folks. Richard's run stuff he downloads.
Yeah, well, we all do, right? And I would love to have something where I just had this confidence that I don't need to audit the whole thing. I just need to look, what platform are you using? Okay, it's a sandbox one. Great, done.
I think this is a really interesting idea because I've only sort of come across this maybe a couple of times before, but it seems to have, people aren't really talking about it. It seems now, but 5 years ago, there were lots of people talking about unikernels for a different reason. This was about security and about the kind of, the different, the surface, attack surface area, essentially.
Yeah.
Right? Can we limit the amount of stuff we're going to compile into our OS so that it's not available? You can't even use any of it.
Right.
It's just not there. And I think I had a line at one point like Docker 30% of the way to unikernel. It was like that kind of thing. That was 5 years ago. Not really talking about it, but it seems like in some ways a similar idea, but coming at it from a different perspective.
Yeah. It's definitely about. I would say the thing that you have in common there is the idea of security through just like absolutely not making things available in the first place, rather than having them be available and trying to make sure you played whack-a-mole and locked everything down. Right, just saying like it's not even there by default, and we're only going to opt into giving you access to the minimal set of things necessary to do whatever you need to do.
Cool. And what sort of language is it? Is it a purely functional language? You said it's functional. Yeah,
it's functional, and I would say like Elm, there's a very heavy focus on usability and user friendliness and stuff like that. There's different sort of schools of thought of like functional programming languages. Yep. So I would say that like Haskell is very focused on like mathematics, or at least like it culturally feels that way. Maybe different people would disagree with that, but and I would say like Clojure is a very like it's all about Lisp and like macros and like these particular set of primitives that are not necessarily required for functional programming, but like fit together in interesting ways with functional programming. And like Elm and Rock are very much like typed, pure functional, very focused on like having a small set of simple language primitives that work well together, and then really nice compiler error messages and ergonomics and stuff like that. So we do stuff like, and also I would say we're On the tooling side, we're drawing a lot of inspiration from Go, where we're like, we have the test runner built in, we have the formatter built in. We want to make it so, you download the rock binary and then you can just go. You don't need to, pick a bunch of things off the shelf, to get things that everybody agrees you should have a testing system, but you don't need to go pick one off the shelf. It's just like, it's there, it's right there, built in.
And have you sort of taken the same, talking of Go, have you taken the same decisions around things like testing with, or is it Rust? With Rust, you test inline. Do you have the tests in the same files?
You can do that, yeah. So we do have inline tests. The keyword is called expect, so you can just like write your function right below it, next line, expect whatever, and then you're done.
Super cool.
Actually, I guess a nice example of ergonomics. This is always something I'd liked. Power assert is the one that comes to mind that I use, and I also back in the day I did a little bit of development with Groovy. And they had that built into their tester, and I always thought it was cool, is that basically when you run your tests in Rock, you can just write normal Booleans. Like you don't need to do like exert, assert, this or that. You just say like, expect x equal, or, foo x equals 5, and that's it. And what it'll do is, if that test fails, is it'll show, first of all, it'll print out the source code of the actual test that you wrote, and then also any named variables that you had, it'll just tell you what their values were. So you don't have to go back and be like, oh wait, what was this? Just trying to give you, and we've also talked about maybe expanding that a little bit to tell you like what's on either side of the equals, or if you did like a less than, show you those things because you might want to know. Basically, just try to give you the info that you want anyway, and don't make you go back and like debug log the test.
Yes. Ooh.
That's the first thing you usually do anyway. Right?
Yeah. Well,
so might as well save you the trouble.
Yeah. Yeah, I was always of the opinion. When I don't write as much code as I used to anymore. Has to be said. But I was always of the opinion if you use the debugger, you're failing somehow. But it was I come from a very sort of purist TDD kind of background, if you like. So.
But regressions still happen.
Yeah,
right?
of course. Yeah. No, I know. Yeah. Cool. So I mean, so are you seeing? So is it out? Is Rock out now?
I would say it's pre-release, so we don't have a numbered version yet. You can download a nightly release. We're in the process of making a real website right now. Depending on when you watch this, maybe it'll be out. But right now, like as of this exact moment, there's like kind of a placeholder website that sort of describes the language, but it's very bare bones. But now we've gotten to the point where it's actually useful for things. So prior to this point, like last year, I would say like, well, you can try it out and play around with it, but it's not really that useful. But now it actually is useful. I would say it's useful, but very immature and early, and definitely there's bugs and stuff like that. But you can like build stuff with it for real now. And now that we're at that point, we're like, okay, now we need like a real website, and so it's ready to be used by early adopters who aren't afraid to sort of roll up their sleeves with the new technology. But actually, like I have a lot of fondness for my time at the beginning of Elm, because on the one hand, when you have a small set of people using the technology, yes, there's sharp edges and bugs and stuff, and things aren't, the ecosystem's not there yet. But on the other hand, I used to work with Bill Venners, who made Scala tests. And I remember thinking, like, how could you have made something that's used by so many people? And I asked him about that. And he's like, oh, it's very easy. Back then, there was no testing thing, so I made one. That's how it is in the early stages of a language. Somebody's got to be the first person to write whatever X is for that particular, use case.
My programming career goes back through, before Java, essentially. And that sort of completely changed my life, right? So when Java came out and the internet essentially, or the World Wide Web, and Java really sort of changed pretty much the way I think many programmers went about their job. But the interesting thing with that, especially in Thoughtworks, is everything was a first. Everything you were doing was a first in a lot of ways. The kind of the testing frameworks were a first. The continuous integration servers were a first. The acceptance testing frameworks like Selenium and they were a first. All these sort of things were the innovations that were happening were because people were hitting these issues and then kind of trying to come up with a way of solving a problem that they were experiencing on a day-to-day basis. And I do sort of wonder now, are we still seeing that, or are all these sort of solved problems now? It's just when we have a new language, say like Rock, we need to create the test runner for them, and there's someone who's going to be the first person to do that. There's someone who's going to be the first person to do X, rather than it being, or another example would be things like machine learning, applying engineering discipline to machine learning. So, there was a period not so long ago where the idea that you might version control your model was like a crazy idea. Why would you think about it? But that's now a kind of normal thing. So things are repeatable and so on. Is this a case of sort of we're applying, I guess, a set of tested and known patterns to the new things? Is that a kind of...
I'd say it's a mix. So an example that comes to mind is, so in Rock, we have, as far as I know, Unic, I don't know of any other language that does it this way, approach to serialization and deserialization. So two different ways that this is like commonly done today. So there's like the JavaScript way and the Ruby way where you get some JSON in and you just say like JSON.parse and it's like, cool, now you have a JavaScript object. And of course, the downside of this is, you get partway through your program.
JavaScript.
Yeah, and then like, well, what if the JSON doesn't match what you thought it was going to match? You're going to find out about that eventually, but it might be pretty distant from where that original problem happened. So that's one way of doing things. Another way of doing things is, I'm thinking of Rust, but I mean, I know in Java you can do it the same way, where you basically have a schema up front, and you say, so this would be like Jackson in Java. So you say, here is exactly what I expect it to look like, and come in, parse the JSON, and if it doesn't match that, fail right away, right there. So that, in terms of how easy it is to debug later, I would say that's easier to debug later. But a downside of that is that you do need to actually write out the whole schema and sort of keep it in sync with your program and so forth. So something we've introduced in Rock that as far as I know is novel, is that we kind of have both. So you can write at the same time. So you write the equivalent of like JSON.parse, and it does just you don't have to write a schema, but what it does is it uses type inference to infer the type that you're parsing into, and based on how it's used in the rest of the program. And so it actually will decode it right there at the call site. And if it doesn't match how you're going to be using it throughout the rest of the program, it fails right away.
That's super interesting.
Yeah. Now, what's interesting about that is that that's not specific to JSON. It's something that's just like, we call it, decoding is the general term for it. So in order to make it work for, let's say, JSON, somebody needs to write a particular like JSON aware parser that works with this framework so that it can translate between JSON and Rock values. So on the one hand, you could look at that and say, well, this is just somebody needs to write a JSON parser for Rock. But on the other hand, structurally, it's different from how it's done in other languages. It's not like you're just translating it into a normal
I think is there a TypeScript library called IOTS or something like that?
I've heard of this, And now I believe that
things.
works like it works in Java and like Elm and Rust, where you do make a schema and somehow you define in code, like you write some code that does this. I assume, I don't know for sure, but I assume that you either write it by hand or there's like you run some code that generates it or something like that. But as far as I know, in TypeScript, it's either you do that or else you just say JSON.parse and that part's just not type checked.
Yeah, right.
But the point being, like, if you're writing this, it's like you're doing it in a different way than has been done before. But on the other hand, it is still just, for JSON, for XML, for CSV, whatever.
It's good. We're talking about functional programming languages, and we finally got to the point where something's a bit monad-like, which is good, right? Because that is interesting, right? Like, so that's why I found it interesting about TypeScript, and you pass this stuff over the wire, and you've got this lovely sort of type safety within the environment you're working in, which is the front end. But as you say, like, you could be sent garbage that is essentially you've got no way of knowing until you try and parse it, decode it, whatever. So I kind of like the idea that actually there's maybe an attempt to solve some of those problems where you're actually being type safe across the entire I guess back, front, end, etc. And across the wire. And one thing I do, because I did a lot of integration, a lot of XML parsing in my day. And we used to use XML. We used to what's it called? XPath. That was the thing. Where rather than do the kind of like take the schema, basically have a client that's generated from the schema, and you kind of when you receive a message, you turn that into the object, and if it doesn't match the schema, you blow up. You'd say instead of that, you'd use XPath to just pick out, and Schematron actually was the thing. You'd pick out just the bits from the message that you wanted, and then therefore you would know if you were insulated from changes to the schema, if you like. So, if someone changed the schema, you weren't suddenly going to blow up. Because this is the main problem, right? I mean, how do you avoid that issue of essentially just falling over in a heap if the thing that turns up isn't what you're expecting? So if it doesn't conform to
So
if you can't decode it, right? Do you just blow up and just like, sorry, we're done?
That's well, the default is, I mean, it's not like throwing an exception. It's just like you get back a value that says either it succeeded and here's your answer, or it failed and then here's the error that it failed with, such as like this field was missing or something like that. So recovery is sort of up to you as the application author. It's not I don't think there's a one-size-fits-all way to recover from data being missing.
Which it's the build time versus it's the compile time versus runtime checking of these things, right? So that's what we used to do. We used to do it at build time. So we'll generate a library based off a schema, and then that library is going to be quite fragile in the face of changes elsewhere, if you like. And you'd have to rebuild, recompile your application if someone's schema changed somewhere, which sucked.
Yeah. Now, having said that, if you want to write something that is more flexible at runtime, like you can say, well, it's okay if this field is missing. I want to default to this or that. You can do that, but then at that point, you need to, at least in Rock's case, you would need to sort of, I'm going to use the term eject, translate the automatic thing that's happening into like an actual written out schema, like a decoder that you can then customize. So this is how we do it in Elm, is it's always done that way, which makes it very easy to customize. Another nice thing about that is if you have it all written out, that it means that if you want to change your variable names or something like that, you can do that without worrying that you're accidentally causing a regression in the decoding, which hopefully a test catches, but it might not. But then again, there's another trade-off there, which is that when you have it all written out, it becomes a little bit more brittle to internal changes. Like, so if I need to add a field somewhere to that happens to be in a data structure that's used quite often throughout this thing, I have to go through and change it in a bunch of different places. So certain things like being synchronized either can be a source of bugs or can be a source of convenience, and it's just an innate trade-off. But if you do sort of eject the decoder and have it all written out, then you can be a lot more flexible in terms of if the runtime value is this or that, or this is missing but that's not, or I can say, well, I'll accept any of these three names here and I'll just internally convert them to the same thing. So a lot more flexibility if you go that route.
I feel like we've gone quite deep into some random part of the language, which is like parsing responses. But let's maybe chunk it up a bit. So what are you excited about in terms of features?
For Rock?
For Rock, yeah.
Great question. So, that is, to be fair, one of the things I'm excited about. So in general, it's 100% type inference. So you can, you don't need to write any type annotations if you don't want to. I mentioned that it's fast, friendly, functional. So in terms of fast, the thing that I'm excited about, there's two parts to that. One is really fast compile time. So we spend a lot of time doing that. We still have a number of projects to go, but one of the things that, you mentioned like TDD earlier, one of my hypotheses for why there's a really strong testing culture in Ruby, like for example, and I think in Python also, more so than I've seen in type checked languages. I think part of the reason for that is that you get a really fast feedback loop when you have a dynamic language for two reasons. One is that there's no compile step. So we want to just make our compiler so fast that you don't notice it. But the other part of that is that from a workflows perspective, if I am writing a test in Ruby, or let's say I've got a bunch of tests and I'm refactoring something. All my tests go red because I've changed this thing. Okay, fine. Well, I can go and fix them one at a time. I can go change my implementation and fix whatever, and they go green one at a time. Now, in a type checked language, the norm today is that I make my changes and I get a bunch of type errors, and all my tests are not runnable anymore until I fix every single one of the type errors. So the whole make the test green one at a time by fixing implementation details, that workflow is inaccessible until you fixed every single one of the type errors. But quite often, I don't want to do that. I want to go through and change the behavior one at a time and make sure that the new behavior actually passes all the tests. And then maybe there's still some leftover type errors because I changed the interface, but those are just going through and updating callers to do the new thing. In isolation, I still want to just do this thing. Or let's say I'm trying something out because I think the new implementation will have better performance, or I'm trying something out and I just want to see how it feels to use it. Again, I don't want to have to go and fix every single implication of that. So this gets me to another thing that I'm excited about, is that we've designed the compiler. It doesn't 100% work this way yet, but we've at least designed it, and we'll get to a point where this does work this way, where basically the compiler always type checks your code and always tells you about problems, but they don't block you. So you can still run, even if it's got type errors or naming errors or whatever. So the idea is that much like a dynamic language, you still have those workflows available. So I want to get that same experience. This is always something I missed when going from dynamic to statically typed languages, is that workflow of I can always run my tests no matter what's going on. And I can see which ones fail. And, if they have a type mismatch, fine, that's a failure, failed test.
Yeah.
But only if that affects that test. If the type mismatch is some distant part of the code base, I don't want to see that. Don't block me. Just let me run these tests, and I'll come back to that later. So that requires sort of building the whole compiler with that in mind. And it's, when I say it's not ready yet, it's because like there's stuff that's like has bugs that we need to fix. But really, I'm really excited to use that. Like when I get to a bigger Rock code base.
That does sound like a really interesting feature, a really cool feature. Yeah.
Yeah, because I like both. I like having the workflow where I tell me about the type errors up front, and I also like the workflow where sometimes I just want to run the thing and see what the answers are.
Yeah. Well, it's become quite common, or certainly. I quite like using, kind of basically monitoring the file system for changes and running your tests every time there's a file system change.
Yeah.
Which kind of blows that completely out of the water, right? If suddenly a type error is going to stop,
right? It's like they all failed.
Everything's gone, right? Because
zero successes, 100% failure. Yeah, thanks.
No, that's actually really cool. Yeah.
So one more that this is in the design stage, but it's again something that we've designed the language around, and the platforms and applications, and also the fast runtime performance is a big part of this. But something that I really want to exist in the world, and we're going to make it happen, is. So package ecosystems, I think, are one of the, after like garbage collection, have been like one of the biggest like levers for making programming like a lot easier and making people more productive. And when you get a package, like I install a new package, I always get the code, and then I get the documentation. And then sometimes, occasionally, there might be, if it's like a really popular, widely used package, I might get separately from all that some editor tooling for my particular editor. So you get like I think like the React community has done some cool stuff with this. So like I remember like the Redux dev tools. I know Redux is not like fallen out of favor, but I do remember like, people built tooling for that, and like, but it didn't run in people's editors, it ran in the browser. And I think that was like kind of a hint of like, hey, our packages and stuff, we could be a lot more productive with them if we had tooling for them. But in a lot of cases, people don't integrate them into editors because it's like, well, what, I'm going to write, you like VS Code, and this person likes IntelliJ, and this person likes Emacs, and this person likes Vim. I'm not going to write, 10 different implementations of this. And so what ends up happening is that you get zero implementations. People just don't bother doing it at all. So what we want to do is we want to solve this at like the language level. And my specific concrete goal is to make it as easy to write editor tooling as it is to write a function in Rock. Like you can just write a function and press enter, go down a line and write like a piece of editor tooling right there. And that gets distributed with packages. So it's just part of the language. And when someone implements like the VS Code, Rock extension, part of what they do is they implement a way to handle these things, because we have sort of a, it has to be kind of a simple vocabulary for this. I realize that, of course, we want these to be accessible. And if you're thinking with accessibility in mind, you already have to have the language for describing these tools be pretty general, so that it can either be rendered on the screen or rendered for a screen reader or something like that. And at that point, you can sort of adapt that to whatever primitives, like Vim has different primitives than VS Code, which has different primitives than IntelliJ. But if you're describing the functionality that you want at a sufficiently high level, the hope is that I can, we talked earlier about like exporting JSON, right? Or ejecting it, right? I would love for the JSON package that I install just to add like something to my context menu where I can just say, hey, see this like, type inference based JSON decoder. I want to just right click on that and say extract explicit decoder. It's like, here it is.
Nice.
Right. And then that works in Vim, and it works in Emacs, and it works in this. And it's like nobody needed to write a separate plugin for each of those. It's just the Rock extension means that when the author of that JSON package shipped, they included that little bit of functionality, and now everybody gets that. And if they want to do the customized version, they can do that. It's totally trivial. That's exactly the type of thing that I think could make the Rock ecosystem just do unprecedented things, where you have this like everybody can not only ship the code, but also this tooling that's like a force multiplier for everybody else. And then everybody's a multiplier for everybody else. That can be a compounding effect that I think would be really powerful. And that's one of the things I'm most excited about with the language. I could go on, but that's...
No, that's very, very cool. It reminds me of, I think there's something called the principle of least surprise, right? The reason I love certain tooling over other tooling is because it just lets me... I can almost guess like how to achieve a particular thing. I need to extract a method. I wonder if I do that. Oh, cool, it works. But I like this, and it's sort of like tooling that's designed that way, I think, is incredibly powerful, because it just, as you say, it acts as a force multiplier. So the idea of building that actually into the language tooling, I think that's super interesting. Maybe we should chunk up again. What else are you excited about that's going on?
In Rock or elsewhere?
Elsewhere, just in general. Maybe one or two things.
I'm very excited right now about learning more about performance optimization on a personal level. So this was something where, like, when I was in, as you would say, university. In Americans, we always say college for some reason, even though it says university in the title, whatever.
So bizarrely, I was actually in a college, but it was a university, so it's all good.
Yeah, who knows? I don't even know what the formal difference is between them, to be honest. We use them kind of interchangeably. But when I learned about performance optimization, there was a very heavy focus on asymptotic complexity, and, like, as n gets bigger, the number of elements get bigger. What does the behavior look like? And the sort of the stated reason was for doing all that was this is some knowledge you can have that translates across hardware, because different CPUs have different optimizations and yada yada, and that was sort of hand waved away. And the more that I've gotten into, because, like I said, I'm trying to make Rock's compiler really fast. The more that I've learned about, okay, but actually you want to make it run fast on particular hardware, like the modern Apple laptops or Intel servers or whatever. There's a particular set of, like, techniques that you use that do need to know about the hardware. Yeah. And there's, like, as I have more and more come to learn, like, the stuff that we learn about the asymptotic complexity is really just the tip of the iceberg. And if you really want to get stuff going fast, it's like, now I'm learning about, like, CPU memory caches and TLBs and virtual memory and paging and SIMD, and there's this great talk by Andrew Kelly, who made Zig a couple years ago, where he talks. It was at Handmade Seattle. I forget what year, like 2021 maybe, something like that. Maybe it was pre-pandemic, might have been 2019. But he basically talks about how he made Zig's compiler a lot faster, and he's not talking about any of that, like, asymptotic complexity stuff. He's talking about, like, here's the memory management techniques, strategies that we used, and data-oriented design and structure of arrays, and, like, we're trying to avoid CPU cache misses. That's the name of the game, and all these things. It's this whole world that I didn't realize how superficial my understanding of it was, and it's been really exciting to, like, get into it and be like, wow, I can make things so much faster than I realized.
Are you familiar with Martin Thompson's work on this? He talks about the idea of mechanical sympathy. For many years.
I've heard that term, but
mechanical sympathy, which is this idea of being sympathetic to the hardware, right? But what I find fascinating is, because we moved away, there were so many levels of abstraction between the code that you're writing and the hardware that's running on these days. That actually that's sort of, I wouldn't say fallen out of fashion, but people, I don't think people think enough about it, certainly. But of course, where you want to think about it is in the compiler, right? You don't want to be second guessing that.
I mean, the way I think about it is something that's been pretty consistent in my career for the last, 10, 20 years has been, like, trying to work backwards from the user experience I want. And for some applications, the performance is not a big concern there. It's just like, well, you're going to be bottlenecked on the database, and the database is going to be about as fast as the indices you set up for it, and that's kind of it. I guess if you wanted to, now I know enough that I'm like, okay, if you really wanted to, you could roll your own database alternative that's highly optimized for your specific use case. But in a lot of cases, it's like, yeah, but people don't care about that performance difference. They're like, they're going to be waiting for the network anyway, so you're never going to get sub-millisecond,
and they probably wouldn't pass the Jepson test anyway. So
no chance. Your hand-rolled database probably. But there's a lot of use cases that I can think of where I really do want, like, performance is part of UX. It's a big part. And a compiler is absolutely one of them, where, I like Rust in a lot of ways. I'm very frustrated by the compile times a lot of the time. Especially the caching. Like, there's part of it is, like, how fast is the compiler, but also, like, which work is it doing? And on some level almost wish they didn't tell me this, but sometimes I'll be rebuilding my project and I just made one little change, and it's like, hey, I'm recompiling your, like, JSON crate, and I'm like, what? I didn't do anything. What? Why are you rebuilding that? Nothing has changed. And I'm sure there's someone can explain to me why it needed to do that. But there's now that I have more of an appreciation for, like, oh, it doesn't have to be this slow. I don't have to be sitting here waiting for this. It's all the more frustrating when the tools I use, whether they're compilers or otherwise, are slow, and I know they could be. They don't have to be.
Well, I think there's another. I think there's another reason, I think quite serious reason actually these days, to think about mechanical sympathy as well as user experience is a fantastic example. But I think actually the amount of energy we're using is a super important consideration now. And if we can be more sympathetic to the hardware we're running on, then potentially we need less of it, right? And that can only be good, I think, given the state of the world at the moment. So
I'm curious about how people measure that, because we have one of the Rock server projects that's in progress right now. We got a research grant to do it. We probably don't have time to go into all the reasons why it's novel and interesting, but it does like interesting memory management behind the scenes. And basically, so it never has like garbage collection pauses or things like that. And there was a researcher who was not directly related to the project, but who became interested in it because of the question of, could this mean that you have servers that use less energy? Because garbage collector, in addition to slowing down your UX, also requires energy to use. And that led to the question was, how do we measure what the difference in energy is? And I guess that researcher knows more than I do about that. But it's something I'd never even thought about. Is like, put a number on it. What number do you put on it? How do you measure that number? I have no idea.
Yeah. I mean, it's certainly something we've been looking at in Thoughtworks, because it's sort of there's some interesting design decisions around things like even like how often you build, right? So we're used to hey, we'll commit and build and deploy 1,000 times a day.
Yeah.
Well, that's actually like pushing, like that's actually pushing your code through quite a few potential stages of a pipeline.
Yeah.
That's quite a lot of CPU cycles you're doing every time you're doing that. So is there some, well, there will be a function, there's going to be a function, probably a U-curve optimization, where you're going to be looking at like the optimum number of deploys per day.
Yeah.
In order to, when you go over that, you're going to be like using too much or more energy than you need to for the amount of value you're getting from the software. Anyway, I think probably, Richard, we should probably call it a day there.
Yeah.
We've covered an awful lot. So thank you so much for coming along and chatting with us today. It's been brilliant.
Thanks for having me.
It's been awesome.
It's been
really
fun.
Interesting. I'm super excited and looking forward to checking out Rock.
Awesome.
So thank you. This is James and Richard saying goodbye from GOTO Unscripted at GOTO Copenhagen. Thanks very much.
Thanks.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.